Hey, good morning. Back at you with another live video. Going to be continuing season two. Wanted to drop a couple things out real quick though. Been an interesting week. Last week we saw the release of .NET 5, and I think it took 2 days for someone to ask why I didn't support EF Core 5, or I'm sorry, EF5 now. Core is out of vogue apparently. That's the old thing, and now we have the new thing. I will be releasing version 707 shortly, probably later this afternoon. It's going to have just minor bug fixes, not a whole lot, nothing major breaking. Few package updates with .NET 3.1, I guess, kind of settling around 3.1.10. I've updated some of the packages to that for the latest .NET Core 3.1 SDKs. And we aren't going to move MT to where it requires .NET 5, despite that being available now. .NET 5, again, is a .0 release, so it isn't going to be forever. But we'll see how it goes, and we'll see. I'm hoping that it's backwards compatible, but we'll see what happens. I mean, I looked at the EF Core to EF5 upgrade guide, and I didn't see a whole lot there. So, it just seems like we're going to be good to go there. So far, no problems. I have the .NET 5 SDK, and I'm working on some interesting enhancements for things like the request client with some of the pattern matching capabilities. And honestly, they're a little weird because everything just boils down to object. So it might be cool and it might not, but definitely keep an eye on the Discord, check the GitHub issues for any new features coming out, and the release notes for 707 are actually already up on the website. So with that, I'm going to jump into some code that I thought about today. Season 2 has all been about the state machine, and one of the things that constantly keeps coming up for me, and I see a lot of articles out there, and let me throw one up real quick. I mean, again, let me see if I can bring this up. Nope, that's not what I wanted. I need another window. Here we go. All right, so if I change the size of this, and Drew keeps me honest about all the different, I guess they aren't really competing, but the mind share of what the world is going into in terms of the microservices issue, and how we've created a gigantic mess of decoupled independent services that have nothing going on realistic. They're just hard to operate. They're hard to maintain. The monolith was easy. We did a big push on Thursday. We hope everything worked Thursday afternoon, and then we all went home for the weekend. It was a happy place. Deployment was easy. Operations was easy. It was all one database. And we figured out that that was bad and too easy, so we made it very difficult. But cut to the chase, this Stack Overflow article and many others like it. I mean, I've heard of temporal before, but there are a lot of solutions coming out that deal with the state problem. Everybody said, oh, we need to build stateless services. Well, hey, it turns out you actually need state. And this is one of those things that MassTransit has, and Season 2 is focusing heavily on the state machine, because the Saga state machine within MassTransit allows you to solve a lot of these problems. And the interesting angle that's coming at it is temporal, is doing a lot of the similar things. They're doing it with a different style and a different language approach. But the one thing that I find that they're adding that is interesting is tooling. Things like the ability to query the state store and find out what the state of an operation is, or the ability to send state manipulators into the state store to say, oh, okay, well, I need to force this one into a new state because I want to unlock it. I don't know if that's something that I'll eventually get to with MassTransit. I mean, that definitely feels like a commercial type thing, and that is something I definitely don't want to spend a whole lot of energy on at this point. It's hard enough keeping up with MassTransit as it is, and that's kind of where my key focus is. But it's something that I'm definitely curious to see what people's thoughts are on, because between routing slips and state machines, you really have all the tools you need to build fully reliable distributed transactions that support retry, timeouts, everything. And as we've gone into the extensive details within this season around the state machine, I think we're really showing how to unlock some of those capabilities. So, definitely a space to keep an eye on. Look at, the competing systems out there. It's just good to see what other languages and what other solutions are coming up with, and see how that fits into the ecosystem. So that's just kind of the intro. just like people are saying in the chat, everything is stateful. Everything has state. Something changed and it's in a current state. So to say we're going to have stateless services, you have to have some level of orchestration with that. And I think we're in a better place moving away from two-phase commit and distributed transactions and doing things like routing slips, where compensation is part of the equation because it is a distributed transaction. But it's really just language and tooling. It's still something didn't complete, so we roll back the other thing. So again, just some place to keep track of, something that's constantly on my mind as I think of how to make mass transit more approachable. And my current mindset is that creating these videos and showing how this stuff works and putting the sample code out there is a lot more useful than thoroughly proofread and correct documentation, although the documentation does help. But looking at like what's in version 8 and version 9 and what everything else is where are we going to go and what capabilities are we going to add? Those are things that are front of mind for me. So with that, I want to get into this episode, and this episode is going to cover a new state machine that I've already started writing because I wanted to see if I could do it first. And so when you get the code for the latest episode, it's going to have a little bit of boilerplate already done that we didn't do on the fly, but I wanted to kind of think about the domain a little bit. And again, the domain this season is all about the library and checking out books. And the feature that I want to cover today is the composite events capability of the state machine, because I feel like this is misunderstood and it has some configuration tweaks when you think about the ordering of events. And there's just some complexity in using it because, again, it's managing that state across a number of different events that could happen. And it's doing it in a way that there are many ways that this can be used. The case that I'm going to show today shows two different events that happen and how we want to do something once both of those events have happened. Thus, the name composite event is it's multiple events that are then combined to produce a third event. And the approach that I've taken is we've gone into our library and we want to thank a member for using the reservation system. So instead of just walking into the library and checking out a book, when a member walks into a library and checks out a book that they had previously reserved, we want to be able to thank them for that. And I mean, this is the most ridiculous example I can think of, but we want to thank them, and maybe for trending and analytics, we want to keep track of this as well. I don't know. You make up anything. It's a domain. I came up with this answers. This is what we're going to go with. So to do that, I've created a thank you state machine and put the initial thank you test out there. And the test that I have in this place is when a book is checked out via reservation. And there are two events that I want this state machine to be interested in. The first one is the book reserved event, which is produced when a book is reserved. And that includes a number of properties. In this case, it has the reservation ID that was used to reserve the book, the member ID that reserved the book, and the book ID itself. At least those are the ones that are interesting to us in the thank you state machine. The other event is the book checked out event. And the checked out event is the one that's generated when a book is actually checked out. And it includes the member ID and the book ID. Notice that in this case, the reservation ID is not present in this event. So when we look at the state machine, how do we want to correlate these events to the state machine? Well, first of all, we have to have a current state, which I haven't created any states yet, because again, I just wanted to get the cruft working. But I have two events, book reserved and book checked out. And in fact, I can get rid of this because I'm not using any built-in correlation. For the book reserved event, I want to correlate this off a query. And so because we're using a query, we aren't matching to an individual Saga instance. It could actually be multiple. And in this case, I want to say if the book ID matches and the member ID matches, it's the same one. And maybe that's a little weird, but I think it's okay. I don't think it's going to kill us. Because that's all we're doing is we just want to thank the member that they reserved a book via the checkout system. I'm not going to go too deep here. But we're doing a query-based correlation. Now, when you do a query-based correlation for an event, the state machine doesn't know what ID to assign to the state machine instance. So we have to specify a select ID statement which tells it which ID to use. Now in this case, I'm going to use the message ID because it's an already generated GUID It's part of the message that created the instance. And if I process this same event again, it's going to be the same message ID. So at least I have some thoughts of consistency there. And if for some random reason there isn't a message ID, I'll just create one, because honestly, it doesn't matter. I am not correlating by that ID anywhere in the saga. The next event that I'm handling is the book checked out event. Again, I'm going to query for this one. And in this case, I'm also going by book ID and member ID. So again, I'm also using the message ID to correlate it. And I'm doing these both. An interesting note about this is because I'm correlating by something that isn't the correlation ID of the saga, chances are I'm going to need to go into the repository that I store this in. Let's say I'm using EF with Postgres. And I'm going to, in the class map, have to actually tell the database underneath through the code first thing that I actually want a unique index on book ID and member ID as a composite index that prevents duplicates from being inserted. And the reason for that is because since we are correlating to an instance based on book ID and member ID, we want to ensure that only one instance is created in the Saga repository. So we are going to enforce that by putting constraints on the underlying repository. For EF, it's pretty easy. I think you just do an index statement in the class mapping that includes the two different properties and say that it's a unique index. I think with MongoDB, you can create a unique constraint somehow. Various databases do it differently. Redis, you can't use queries, so don't even try to do this with Redis, because Redis doesn't support queries for sagas because it doesn't support queries. But now that we have those two events defined, let's go into the test and put put handling of that. Now we're going to assume for the cases of this scenario that these events can be produced in any order. We aren't going to require that they're produced in a specific order. So we are going to say initially, no, I'm not going to ignore, when book reserved, we are going to copy some data. And in this case, we're going to say context.instance.bookid equals context.data.bookid. And here's another important thing to point out. Even though I've correlated by these properties in the event definitions, there is nothing in the state machine that knows how to initialize these properties. And that's important to understand, because if I don't copy those values in here, the index isn't going to be able to update because those properties will be null. So just like book ID, we also have to do member ID. And because we are reserving it, we have the reservation ID. So we will copy that as well from the initial message. At this point, we are going to transition to just an active state. Why not? We'll create a state called active. And that's just going to give us a place to hang out. We'll add active up here to our integer current state map so that we have all the states in our instance state. And that's our book reserved event. Now we're also going to add another one, which we'll copy in here. And we'll say when the book is checked out. We won't have a reservation ID, so we won't copy that, but we'll also transition to active. So now with either of these events happening, we can copy the data, initialize the instance, and then transition to that active state. Now, we also have to come in here and see if I can select all this and say during active, because these events could come in any order. And in this case, when we get a book reserved, we already know the book ID and member ID are there, so we just want to copy the reservation ID. When the book checked out happens, again, we already know these are here, so we don't even really have to do anything. We're already in active. In fact, there's nothing to do here. So in this case, we'll actually just ignore book checked out because we don't care. Great, so we have two events. They can happen in any order, and they'll always get us into the active state. And we can verify that by looking at our unit test here. So if we have a book reserved now, we should verify that it consumed book reserved and that it created a saga instance with that correlation ID. Let's see if that actually works. This is the first time I run this test, so hopefully it actually does. And it doesn't. So what did we do wrong? What's in line 34? Created correlation ID equals book ID. Oh, well, yeah. It isn't going to equal the book ID because, well, frankly, we don't have the book ID. But let's make our test a little happier. Actually, no. Let's just, let's not care about that. We want to make sure that we consumed and that we created a instance of the saga. Should be great. Saga not created. Let's try it again. All we really want to do is see that we actually created a saga instance because we've only sent one message. Okay, now we're green. All right, awesome. Sometimes it helps to assert what actually matters. And so here we have our created, we have our added. It creates a new saga ID. Awesome. Now, so you can see I'm publishing in here the book checked out. At this point, I can also check, I don't need to check all of these, honestly. I can just check the ones that I wanted to. Let's check that we consumed the book checked out. And that we, well, created any we know is already going to pass. So let's check for the existence, which it's already going to exist as well, because it's already going to be in the active state. So it really isn't going to add us a lot of value here. Oops, what'd I do? And it's in the active state. We'll save that assertion later because we know it's going to be there. We just want to make sure that it consumes it in the actual saga test harness. So let's crank that in there. Hopefully we can see it work, and we still have it good. And if we look at our log here, I'll zoom this up a little bit, we can see that we did a saga created, we added the saga, and the saga actually used the message. So it correlated to the appropriate existing instance, and it didn't create a new one the second time around. If we had broke that correlation, it would probably create like another saga instance, or it would have thrown an error saying it tried to create a new one, and the saga repository did not support duplicates. So that would have happened there. So we're producing these two events, but we're staying in the active state because we really don't have a third state or a second state yet, and we haven't created that third event. So in theory, I could, in the during active, when I receive the next event, try to do something. But the problem is I don't know if the during active is actually a replay of the book reserved event or a replay of the book checked out event or a separate event. So for this reason, MassTransit supports composite events. And to create a composite event, we first have to define the actual event. So we'll define the event as ready to thank. And it's important to look at this. This doesn't have a type. This is a trigger event in autonomous speak, in that it doesn't have an associated data type to it, which, data events are ones that include a message type. Thus the name data in the event. And now I want to define this. To define a composite event, I use the composite event method, composite event, and it's defined just like an event otherwise. And I'm going to say this ready to thank. And because it's tracking state, it needs a property in the saga to track the composite event status. And this can just be an int because it's a bit flag. So in this case, we will say that we want to use x dot thank you state status. We'll just call it thank you status. And we'll create a property in there. You'll notice it can use composite event status, which was really cool when NHibernate had its whole type thing, and that was a big deal 10 years ago. Now we just use ints because honestly, ints are great and they can have bit fields just like anything else. So we're just going to use an int for the thank you status and map that to our composite event status. And now we specify the events that the composite event attaches to that are required to complete the composite event. And this can be any number of events. So in this case, I'm going to do book reserved and book checked out. So when these two events have occurred, have been presented to the state machine, it will then trigger the ready to thank event. And now this is where the OCD stuff kind of kicks in. And the first thing some people are probably asking is like, oh my gosh, why didn't you configure that event up here with your other ones? Well, everything in MassTransit configuration happens in the order that you set it. When you're building a pipeline, every filter you add is added in the order which it's added in the code. And the same thing happens with autonomous. As you're declaring events, they are declaring their appropriate data in that order. And the thing about composite events is a composite event has to attach handlers to each of the states and events for those events to trigger the ready to thank event. And if I put this at the top, what will happen is the book reserved and book checked out events will actually configure their handlers before the initially and during event handlers. And so what will happen is the first event will come in, it'll trigger the composite event and set that flag, and it will then run, say, the book reserved event. And then when the book checked out event comes in, it will trigger that composite event and trigger the ready to thank event before the book checked out event is actually called. So it introduces an ordering concern that can be, well, it isn't non-deterministic because it's absolutely deterministic. It's just not what a lot of people expect. So by putting the composite event at the bottom, what we are doing is specifying that after all this behavior has happened, the last thing we want to do is then trigger any composite events that happen. Now that we have this composite event here, we can then come in and put a during any when, what is the composite event called? Ready to thank, transition to, and we're just going to call this a ready state, because it's the easiest thing to check from the state machine of the state that we're in. And so we're just going to say when we get ready to thank, we're going to transition to ready. Now, obviously, we would put some code to actually thank the user and probably finalize at this point. But at this point, we're ready to thank them. And then I can put an exists in here that checks to see that we are ready, in the ready state. Saga did not transition to ready. And now we're going to say, after we produce that book checked out event, we're going to verify that it was consumed, and we're going to verify that the Saga instance did in fact, this won't work because of book ID. Let's see here. Does any return task bool? How am I going to find that Saga? I knew that was going to become an issue of how do I get that actual Saga instance. Let's see here. We have Saga harness dot created dot. Let's just say select first. What's select want? Let's give it a weird lambda that does nothing, just returns true. And then we'll get the Saga instance of instance. And then we can check that that Saga instance by using instance.saga.correlation ID is ready. Okay, so after we verified that the Saga was created, we're going to select it out and get that instance, and then use that instance to check that it exists. We'll do that closer to here so we aren't tripping up the system any. Okay, so let's run this test, which produces both events, and verify that we get into the appropriate state. And we aren't going to, because it looks like it's taking way too long than it should. Why is it not getting in this state? Totally taking too long. It's probably going to time out. Or I didn't get the right correlation ID. Or I didn't include the one thing that I always forget to include. I always forget to include this. Okay, so we have a log. It actually did some things. It tried to do stuff. It used the saga. I mean, everything did what it was supposed to do. It correlated properly, but it didn't transition the state. And this is the thing that I always forget to do with composite events. Thank you very much. Is composite events by default don't attach to initial. For whatever reason, I thought that that was a smart idea. So I need to do the composite event options dot include an initial. Why do I need that? I need that because without that option, it doesn't bind the composite event observer for either of these two events into the initial event. And there were reasons for that, but in this case, I have to add that so that the initially is also bound. Now, if I run the unit test, and so like whatever first event came in wasn't triggering on the composite event because it didn't have that include initial. Now that I put include initial in there, this test should pass, and it did, thankfully, because otherwise I'd pulling my hair out. So that's how a composite event works. When the composite event is triggered, it's a trigger event, so there are no data events. A common question is like, well, how do I get the message data for the events that were triggered? Well, that's kind of your job to sort of store that data in the context. I mean, you should be storing that in the Saga instance because the messages aren't kept around. You could use some tricks to serialize the message into JSON and put it in a property. In fact, the job service does that. It uses an entity framework core custom mapper to map message types into JSON and then stores those as an nvarchar max. And that's something you could easily do if you wanted to store it yourself so that you had the actual messages and could retrieve those properties from the instance. But again, it's up to you to store that data. MassTransit isn't going to just magically do that for you because it doesn't control your mapping. It doesn't know that you have a property to store the event data. It's a common requested feature, and it's something that I'm not actually sure how I would add it. Maybe it would be like putting an event property on the instance. I don't know. But there are a number of ways to do it, and it's easy to solve by the developer that fits their scenario. So that's something you can do there. So that's how the composite event works, how it's used, how it's triggered. You can put as many events as you want. If we actually were to pull that instance after the first event, and let's see, where's my test? I closed it. But if I were to pull up my test, and let's say that, for here, I haven't published the second event yet. Let's go ahead and get this Saga instance. Again, these are all in memory, if you recall, so I could output anything I want. I could do a console write of instance.saga. Thank you status. We'll do the old school console write line approach. Maybe it'll actually work. And if I write this out, it should be a 1. Yeah, you can see thank you status right here is a 1 because it set that single bit flag. If I were to have fun with this, I could actually switch this around and then probably wonder why it didn't work. But let's say I yank this one down here to change the order of the events. Actually, let's just should handle in order. Let's just create another test here called should handle out of order in other order. And again, we're really just testing that the framework actually does what it says it's going to do here, but we could move these into a different ordering and verify that they work the same way. I always forget to turn Presentation Assistant back on that shows the keystrokes, and I haven't done it all season. I did an update on Writer, and it came up and said, hey, Presentation Assistant has been updated. And I was like, oh, I always forget to turn that off. I'll try to remember to turn that on in the future, but that shows the keystrokes that I type. Maybe it's not a big deal now. Maybe everybody can watch season 1 and realize I know how to use Writer with shortcuts. But again, it's just something that someone had asked before, and I noticed it when I updated Writer. I'm really waiting for the EAP to go GA so that .NET 5 support is all nice and clean inside Writer. I have it on one of my I have the EAP installed side by side, and so I'm able to mess with it, and some of the things are kind of neat. But anyway, random. Always fun. So if I look in here now, when we have the handle in order, handle out of order, you can see the first test puts the thank you status at 1, whereas the second test shows the thank you status at 3, which is weird because why would it be 3? That would indicate that both of the events have already happened. Huh, I would have thought it would have been 2. Huh, interesting. Oh, I know why. Because it's reusing the same saga instance? No. Oh, because it found the previous, okay, because I ran both tests. Yeah, see, this is the funny thing is I ran both tests, so let's put any x dot book ID equals book ID. See if that works. And we should put that here too. And we should put that here too. Oh, I don't even think I have that. Oh, message. Yep. We're just shooting ourselves in the foot. Just run it by itself. It was finding the previous saga instance because the state consists across multiple tests. There, thank you status is 2 because I ran it by itself and we're all happy now. I'm guessing if I run both of these again, this time it'll properly do what it's supposed to do with a separate instance. Oh, it'll blow up. Yeah, awesome. Anyway, whatever. Oh, first, yeah. Yeah, I don't know. Not gonna sweat that. As long as I run the tests separately, everything's happy. And again, it's just a log statement, so it doesn't really matter. My tests are not great here. I'll probably have to clean those up at some point. Anyway, it's just a bit flag, 1, 2, 3, 4, 5. So that means you can support up to what, theoretically 31 or 32 versions of correlated events. If you're doing that, honestly, you probably have other issues. I can't imagine that you would do more than 3 or 4. But again, hey, who am I to judge? I'm not going to put a limit on it. I probably won't give you an error if you go over 30 though, so don't go too crazy. It actually might. You never know. I'm not going to try it. So that's composite events. Hopefully this was useful. I'm going to wrap it up here. The code will be checked in, and there'll be another commit in the commit history. If you go to the sample library project on GitHub, you'll see that each of the episodes has a commit checkpoint on it, so you're able to see what the code looked like at the end of that episode, which can be helpful for some. I've tried to do that as much as possible. So yeah, that's all I got for now. I'll probably follow up with another episode at some point on whatever's next in my list of things for working with the state machines. So take care, have fun, and we'll catch you next time. Thanks.